So I've been working on the AV rig. I go around to conferences and do AV, and so that you guys can enjoy it afterwards and hear stuff and listen to things. And so my laptop was tied up doing that, and I had to borrow my buddy Tom's. So hopefully everything will work because I have not had a chance to run through the slides on his laptop. But a little bit about myself. So this talk, anybody was here last year, BSides Charleston last year? Show of hands. Repeat attendees. It's good that we got a few of you. I wish, got a lot of new faces, which is even better. So this talk hopefully will make some sense because it's a follow-on to a talk that I gave last year. It was called Dungeons and Dragons, Siege Warfare, and Fantasy Defense in Depth. So any of you from last year remember we sacrificed the Black Knight called Admin Dude? We played this little game called Fantasy Defense in Depth, and pretty much showed us how warfare and other things eventually lead to this futility of defense, right? So I'm going to try and give us a little quick recap for those of you that weren't here. And I chose an Austin Powers theme because most of you are trying to stay awake at this moment. Any hangovers? Seriously? What kind of con is this? I guess it's out of college, so we can't actively promote overconsumption of alcoholic beverages. But later tonight, there will be a party somewhere that I'm sure you will be able to do that. And so last year we talked about Admin Dude. And so what this concept was is the progression of warfare. So we got a lot, I know we're in Charleston here, we got a lot of military type of contractors and things like that. Progression of warfare. Anybody understand what that concept is? It's I build, man makes spear, I get shield, I take woman, all those types of things, this progression of now we have the castle and so siege warfare, right? Well, the idea is that we as security professionals are still in the dark ages of defense because we're still very much focused around putting up a perimeter defense that we want to try to make impregnable. And so this leads into this concept, and I'm going to highlight a couple of key concepts before we get into what this is, but one of the things that I ran into last year was I wasn't able to share as much of the presentation as I originally wanted to, and it was because I presented at BSides Las Vegas, and out of that, I was going to share this framework or concept that I called Presentation Layer 6.5, and I'm giving the presentation, and we walk out, and this dude from a very big company walks up, he's like, "You can't talk about this anymore." I'm like, "Well, why can't I talk about it?" He's like, "This is patentable. Somebody will steal this. You are presenting a framework and you don't even realize what you have." And so when I got to BSides Charleston 2 months later, I pretty much was locked up with a couple of lawyers trying to figure out do we have something that we really need to protect? If we, because my intent was to, hey, as security professionals, let's open source something. Let's come up with a collaborative means of trying to fix an issue that we have. And so here we are now, and I can actually share a little bit about this and why, because some lawyers helped us protect it from patent trolls. But so as we talked about the history of this and defense, at first when we first started, you remember back in the day when you got your little Nokia phone, you wanted connectivity, right? So I'm going to talk about, these are two major concepts we need to have this understanding of, is connectivity versus connectedness. And so connectivity was this concept that, oh my God, I can have a phone with me anywhere I go. Holy cow, that's amazing. Oh, I can have a tablet that I can carry my stuff with. And then that quickly shifted, right? You didn't just want your iPad with you everywhere you went. You wanted all the files that were at home on your laptop. The files are in the computer. I'm going to use some very vague and obscure movie references. And if you don't like Austin Powers, there's something wrong with you. But so key concept, right? It shifts from access to access to services to availability of information. And so as we think about what does this really mean, there's a concept called pervasive ubiquity. And what pervasive ubiquity is about the future of connectedness and in the future. In the future. I'm going to use some, nobody's launched anything at me yet. I have a very dry sense of humor, so I'm going to be digging for you might have to catch up or anyways. So pervasive ubiquity, which is this concept of borderless networks, right? Anybody heard of borderless networks? What does that even mean? Nobody really knows. Software-defined networking. You software-defined networking people here, okay, or as I like to call it, the Like, it's a big freaking memory hub, like networking hubs. Anybody? We're in college. Anybody know what a hub is? So what pervasive ubiquity is about is like this concept of like self-routing data, devices being aware of each other, your friggin' milk carton telling your refrigerator when it's out of milk and things like that, so that you can make your shopping list and somebody can deliver it to you or whatever. And so some of what these concepts are is that we are pushing responsibilities of networking, interconnectivity into different layers of the application stack. And so when we talk about why that's important, and we're going to show you why encryption and the implementation, the mechanism that we use for encryption and other things is busted, and why we don't think we can trust encryption. Like, how many of you really trust encryption? A couple of hands. Yeah, okay, yay, encryption. Encryption's a great thing. Is encryption busted? We'll talk about that here in a minute. But the idea is that what is a network? What is what is an application even? What is a file system? Okay, how many of you use Dropbox? Like, where's your where are your files? Is it on your hard drive, or is it in the cloud, or is it both? How do you leverage devices? So this concept of like virtualizing even file systems becomes a little bit more obscured as to what where that perimeter is now. And so we're going to take a moment here and reflect, Mr. Bigglesworth. So the idea that, and I talked about this a little bit last year, is that security and kind of our methodology for doing things now is we harden devices, we deploy products, we monitor them and things like that. It keeps bad guys out, so we draw that line in the sand. This is mine and that is yours. And that if we keep bad guys out of the systems that have the stuff that's important to us, that we can win. Well, how many of you are successful in keeping the bad guys out 100% of the time? Show of hands. I'm audience participation here, all right? I am victorious. I don't monitor anything, so I always win, right? I always love that one. So then but the reality is, and what we as security professionals try to teach people in our organizations, that it's really about minimizing data exposure, encrypting data, okay? Some of you may or may not be doing that. Protecting devices, because you're not going to keep them off of them, right? They're going to get your iPhone. You're going to plug it into the, how many of you have the USB condoms? Anybody know what a USB condom is? All right, sweet. Real quick, USB condom, for those that aren't aware, is it more or less strips out, it takes it down to only 2 pins, so that when you're charging your device at like an airport, that the Chinese can't, I love that. Like, I always love I heard Jason's talk at DerbyCon and absolutely love it because, it's hilarious. I actually do a lot of work in my full-time job explaining to people how, like, the Chinese are often the least of their concerns. And then preparing for an inevitable breach. How many of you prepare for breaches in your organization? Like, very few people. And so what that is, that's proactiveness. So as I'm looking around at these things, I'm looking at technologies, and I actually was on the fence a minute ago, Jason, about which talk to give, because I gave a talk at SkyDogCon and Hacker Halted about how to hack the emergency alert system. And that one's a lot of fun, and I take over a radio station and do a bunch of fun stuff like on stage. And Jason made me like really think, okay, let's show about like how hackers are actually helping fix things. So we're gonna apply our MacGyver principle here, and no, you don't want to use duct tape. That's all I got to say. Bad idea. So last year I talked about this briefly, but this concept of that security is 3D. And so as we realize this, right? Like, I can encrypt all my data and put it on Dropbox, but what's the problem? I can't view it on my iPhone anymore, right? Unless I have an app on my iPhone that can decrypt the data and blah, blah. So all of these things start to compete with each other. So to be completely secure, like to get all these things green, like you kind of get, hopefully you understand this concept of like, you have to protect in transmission, storage, and processing. But then you have the basic concepts of confidentiality, integrity, and availability. And then all of these are impacted or touched by technology, policy, and practice. Anybody do that here? Anybody policy and practice people? And then the human element. So what does this look like kind of right now? Well, and what this is showing is that any of these things can be negated by a weakness in the other area. And so it's kind of warped. I'm going to skip over this because I don't have time for you to fully absorb what this is talking about. But like, this is reality. If it'll go back. Well, oh, it sucks. Sucks to be me. This is kind of reality of what we really face, but like, how can we get it as close to this as possible? Because in my mind, unlike Macomber, who created this concept, and this is called the Macomber cube, so this is not something I created. So that means that instantly it has a level of intellectual capability that is far beyond my own ability. So the reality is, like, from the human element, you're never going to get it 100%. Anytime humans interact with this, at some point we're going to fail in some area that's going to cause security to be lapsed. So when we talk about, I started to attack this problem, like, wanted to understand encryption and how encryption was vulnerable and how security and data in transit and all these other things, how do we get as close to that green as possible? And I, being from primarily a network background, wanted to think about things from an aspect of the stack. And so when I started to look at this, you have a couple of different competing models, not really competing, they're kind of the same. And I'm going to introduce something that I call the software developer model. And this is any software developers in the room? Okay. I want to open your eyes to something. This is in no way meant to be, like, I had one guy come up after this talk at another con, and he was like, that was kind of insulting. And it's like, no, it's not meant to be insulting. It's about how you view. This is like, so as a networking guy, we view 7 layers. Then as you get into a troubleshooting perspective, you're kind of looking at it from, the TCP/IP model or the DoD model or whatever. But then when it comes to software development, it's what device am I going to put this software on? What application package am I going to use to develop it? And what services does it provide me? So like Apache or JBoss or Java or something like that. I want my application, I want to write it one time and I want it to work on as many devices as possible, right? Hello? How many of you like writing tons and tons and tons of code for every single other little device? No, nobody wants to. They want to write one app and it work everywhere. So that's what this concept is. So what ultimately, like a lot of these application frameworks do, is they provide a set of base services and an application framework or API stack to develop on, and there's where your application lives. And so what we're kind of getting towards is that more and more frequently here, where we're using interpreted languages and Python and all these other types of things, it's to make all of this stuff at the bottom ubiquitous. It's to make sure that, like, code works everywhere and it's right across and your data is available everywhere you go and all this other type of stuff. And so this is the slide that's jacked up. So I'm going to ask a question here real quick. Where does encryption live in this stack? And I don't have a gift like here, but like there's a giveaway as part of this. Whoever guesses this question, or whoever answers this question, will get whatever goodie. Everywhere. It exists at one layer, and we're gonna look at it from this perspective, okay? Anybody heard of these standards, or these different technologies? Okay, so would you agree that this is winning, that this works, right? So I'm gonna click back here real quick, and hopefully winning will not pop up, but if it does, I'm sorry. So where do you think encryption is supposed to be? It's in one layer. Even with all of these protocols, encryption is at one layer. Presentation. Okay, now what is that? Makes perfect sense. And who guessed it? Somebody be honest, right? All right there. So if I get a giveaway, it's you. So why does this make sense, okay? So let's think about like JPEG or an image file, right? So the image file isn't the application. The image file, when you encode it like JPEG or PNG or whatever, it's a representation of data in a certain format that's intended to be visualized in a certain way. Make sense? Okay. So where does encryption fit into that? It's exactly the same, right? You take plain text, you render it to ciphertext, and then back. It's a it's a change of format, which is what the presentation layer is about. And so when you look at these other things and people say, well, what about all these other different areas? It's like there is an application stack on all of those in each of these implementations that takes it up to the presentation layer and brings it back. When you run your data through an IPsec tunnel on a Cisco firewall or switch or router or whatever you're running it through, it's going from layer 2 up to, it's taking all the layer 2 traffic, running it up through an application stack and bringing it back down and sending it back out. Does that make sense? Okay. So it's supposed to be at the presentation layer. So when we get it, why is this stuff why is this stuff attacked? It's because we're taking data and bringing it down into lower levels of the TCP/IP stack, and it gets exposed to vulnerabilities at all those different levels, right? So like, why does, like a layer 2 encryption, I'm taking data that, if it's going to be encrypted, should be encrypted at layer 6, right? But now it's going all the way down to layer 2 before it gets encrypted, and then it goes back. Anybody see some flaws in this logic? Okay. Now, I'm not knocking those encryption mechanisms. Those are great things, and the reason they were done were for compromises, performance, maybe we trust things, maybe it'll break other things. There's all sorts of reasons to do this, but because there's all of these, different standards in it, it kind of starts to jack things up. So let's look at, once we get into that big fat layer, that application layer, so we've got session, presentation, and application, and what all exists there, and how does encryption exist in these different places? There's all sorts of stuff that's here to do this, and why is that not going? So when we look at how encryption is attacked, how often, how many of you heard AES 256 is vulnerable? Anybody agree that it's a vulnerable protocol? Okay, it's still the DoD standard AES 256, right? There's nothing wrong with AES 256. So then we had WEP, right? RC4. Everybody's talked about, RC4 is vulnerable. Think it's a bad algorithm? No, RC4 is a great algorithm for what it was intended to do. And so what I want to talk about here real quick is that, hopefully I'm doing okay on time. I have no idea how much time I've spent. Am I really going? Oh, okay. Yeah, I'm all right. So I'm going to, apparently the notes didn't come up here, so I'm kind of flying blind because I didn't change let me see if I can add notes here, because that would be nice to have my notes. Yay, let me. Okay, so when we talk about attacking encryption, we're not talking about attacking algorithms, okay? We're talking about attacking implementations. And the reason I say that is, and we hear some people, how many of you've heard that? I know in the DoD world, people like to talk about that a little bit, they're not really attacking the encryption. And the reason is because AES 256 is an algorithm, right? It's a method for taking plain text and rendering it into ciphertext. So how many of you DoD people, you have a safe, right, or a SCIF or whatever. If you ever look at a vault door, or even if you buy a fire safe, right, you go to Home Depot and you buy a fire safe, how do they rate those? They rate them in hours. Have you ever looked, anybody ever looked how many hours is this device going to survive certain levels of heat and things like that before the stuff that's inside of it turns into a crispy cracker? That's how these things are rated. And encryption is exactly the same way. It's not meant to be unbreakable. It's meant to make sure that by the time that somebody takes the effort to to break it, that it's not worth anything anymore. Okay? So AES 256 isn't meant to take ciphertext and render it unreadable forever. No, it's meant that if somebody intercepts it and we don't want them to, how long is it going to take them to get the information that's in it? And if they do, is it worth anything anymore? Let that kind of sink in for a little bit. It's a very different, for some reason that's, for a lot of security professionals, that's a very odd thing for them to grasp. And I can understand why, but if any of you work on base somewhere and you work in a SCIF and you go up to these crazy vault doors, I guarantee you somewhere on it you will find a number of man hours. Okay, how many man hours is it going to take for somebody to break into that? Why? Because if somebody is determined enough and can get to that door, they're going to get through it. Okay, why do people never break into banks? No, they break into banks all the time. The intent is can we prevent them from getting in long enough so that we can get the resources there to stop them? Okay, and that's what encryption's about. So why is AES 256 so easily broken, when we're using it on our SSL websites and everything? Well, the reason is because all they have to do, and the reason that Heartbleed and other ones were so effective is that we destroyed a session-level service that had a vulnerability in it, and because data came down past the past the presentation layer unencrypted, it was visible to the services operating at that level. Following me? Nod heads. All right, do the hokey pokey. Turn yourself around. You guys are putting me to sleep. So what's happening here is we're not attacking encryption algorithms. We're attacking implementations, and we're attacking poor security architecture and design that is allowing these very advanced standards and very appropriately applied and designed standards and allowing us to like apply. So what happens when we take something from the application level, like in a web browser, and send it down to our Apache server is the Apache server takes that clear text data, puts it through a library at the presentation layer, brings it back down, and sends it down the stack. And because of that, we can see it unencrypted above that layer. So what's the issue with TLS, with layer 2 encryption? Anywhere above layer 2, I can see it unencrypted. Why did it ever go below the presentation layer in the first place? We're going to talk about that. So what we kind of, as I'm sitting here looking at this going, why in the world is this happening? The reality is that there were a lot of compromises that were made. And a lot of us like to reuse code. I'm not going to talk about code reuse or APIs or any of that other type of stuff because that's a dead horse that just doesn't really have a whole lot of value. But we apply. We like to reuse sessions, services, and interfaces, and those exist at the session layer. One of the things that I didn't call much attention to, and I want to real quick before we go too far, is the services that exist in this layer. So some of the things that a lot of us think is like AAA and all that type of stuff, those exist, like all of those terminate at the session layer, okay? So there's no protection for user information beyond that. So once I get to there, and we all see this like bypassing UAC vulnerabilities and other things like, so anything I can get to past that, like anything above that, there is no control for that stuff in modern operating systems or applications, okay? Just gonna throw that out there because it's important. Maybe you'll learn something from that, developers. Like control, sandbox your stuff appropriately and apply it. Not just, so like I say that because like I hear sandboxing all the time and people wonder like how do I get into other sandboxes from stuff? It's like, well, if I attack it at this level and then go up, yeah. So what do we have? This is how we do application development, right? Hopefully it'll stay there for a minute. So we have libraries and other things and OS libraries and other stuff that we access at a presentation layer that we call through our software. And yeah, we have, like, we're going to trust that those defenses, all those other things work, okay? We're just going to, for purposes of the rest of this conversation, we're going to say that we can't do anything about those protection mechanisms, or we're going to trust them, all right? Because they do provide us some measure of protection. User account control, DEP, ASLR, all those things, they provide us a measure of protection. And so ultimately, the issue isn't those things getting compromised that's causing unencrypted data to be compromised. It's, a failure to implement it correctly. And so what if we just like made a standard way for us to access encryption? What if we put something there that was standard that said, application developers, this is not an API that you use as part of JBoss or your Java development thing, your Flash package that you're developing your web apps for, or your C libraries for .NET or anything else. What if we made a standard methodology across operating systems in a standard way? Like, so that's ultimately what this issue is, right? As a software developer, you use those libraries that are provided with the platform that you're developing on, and you trust that they're going to provide you security. And the reality is we've seen, like, yeah, there are vulnerabilities in them and everything else, but so what if we this is where this application layer 6.5 comes from, is, we're not creating anything new. What if we just provided a library that provided a standard mechanism for us to interact and get data and encrypt data? So we more or less bring things out of a sandbox, and instead of taking them down to a lower level, we run that data as part of the our application process through the library. It provides us, we don't block access to the encryption libraries themselves, right? Because tons of other applications are using them for encrypting application layer stuff and everything else. But we take user-generated data, run it through an application library before we present it to a service. Anybody following me?
Yes.
Thank you. Thank you for that. My one true friend. So, anybody see how like something like this, standardizing this method, like providing something standard could possibly provide us a little bit layer of security? So, preparations A through G were total failures. So this is a pretty complicated issue. So we get into some things like, so like when we talk about access control and data control and other things like that, implementing multiple models of access and data protection and other things like this. Like anybody have, I mean, y'all are familiar with these concepts of role-based access versus mandatory access versus all these things. Like none of this really, it all gets kind of crazy, right? And it creates this massive, I don't know, orgy of Venn diagram or something up here. So I'm gonna think about the best way to broach the rest of this issue and skip over things because I'm gonna have to move quickly. What if we could like take some of the best of these things and merge them together and take, instead of just, so we have user protection, okay, which is like AAA services and things like that. And then we have some things like data protection, like where we have metadata and file system journaling and other things. We provide access control to those types of things. How do we take those things and put them together? And like the holy grail for like data and systems protection for quite a while has been like, how do we take things like location-based data, like, you never take your cell phone to Uzbekistan. Like, how are you like accessing, your Gmail from Uzbekistan or something like that, and then apply that, how do we merge all this data together to create, real-time access control, right? We've been trying to do some of this stuff for a while. So what the concept for this patent and the concept for this technology came from was like, how do we not create anything? How about we've got all these different standards and all these different things that are out there, and I'm not gonna read all these off, but I'm gonna scroll them across the screen. Like, how do we take all the latest and greatest stuff that's out there and all the work that all these people are doing, and how do we make this magical cocktail of stuff that can give us a higher level of protection? Okay, how do we implement cryptography? How do we use encryption in a, the right way, or a way that everybody can use that would, not mean that they're not going to get hacked, but it means that we have a lot better mechanism for everybody to interact. Everybody's playing from the same playbook, okay? And so when I started looking around and doing some research on this, I found that there's like a buttload of crap out there. And all of it's completely independent, and it's probably really hard to read, but there are more RFCs. How many of you like reading RFCs? Okay. Yay. Do your happy dance. IEEE and Oasis and all these people have all this crazy stuff for like, GeoZACML, blah, 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 XML with this type of stuff. And it's like, so there's tons of stuff that's out there, but I will put it this way. Every single one of these different little standards is in a silo. Like there is a working group that is developing that in the context of just them. And they generate an RFC from it. So it gets a bit challenging to like try to take any of that and put it together, and you wonder why web developers aren't implementing, XML-based, like geolocation information in standard formats, like why everybody has to do it differently is because reading those friggin' RFCs makes you feel like Billy Madison over here, with the little lost puppy that could. So, so what I presented last year and what we kind of came up with, and I'm going to zip through this and then show you some diagrams of what this patent type of stuff is really about, is scalable per-file PKI encryption for ubiquitous computing with decentralized active access control, file management, data destruction through certificate revocation or archiving and revocation. WTF. Okay, what it pretty much means, that's the one sentence deal, is like we as users, we use applications. How many of you use applications? All right. Those applications now, because of certificate pinning and other things, they get digitally signed, right? That's been a kind of a standard thing. Developers have to sign their code with a key that says that they are them. So, they use that private key to do that, and we load those devices on load those applications on these, and we interact with a user account, right, or an identity that we interact with our devices with, and then hence those applications. And users a lot of times have public-private keys. So what if we made sure that every user had a public-private key? And then we use those applications and we generate data. Okay? So what if we took this, so now once you generate this data and you save it to the hard drive or whatever, it gets synced with Dropbox and everything else, and it's in the clear everywhere it goes, and now Facebook owns it with their terms of service that, like legally castrated you. And but what if we, so then we had this massive thing called PGP. Like, so I create an identity, and I have a private key, and I encrypt my data. And then, but if I want to share it with anybody, I have to know their public key, and so it's kind of a pain in the butt, right? And you got to share keys, and you got to do explicit trust and web of trust and everything else. When I say it's a pain in the butt, it's friggin' awesome. was one of the coolest friggin' security technologies ever, but it just didn't scale very well. And that's why we haven't seen, here we are, however, 20 years later and don't have mass adoption of it. So one of the things that does work really well, though, are domains and domain trusts and other things, and certificate trusts through, like by getting a domain, right? Like SSL and certificate revocation lists and things like that. They work pretty well, right? When you visit google.com or you visit Amazon, you get the little green check mark up there, right? Anybody follow me? Yes. All right, feedback, thank you. Because I'm gonna like sit here in awkward silence from now on until you answer my questions. You can ask Chris Sanders, where was it? Of course he remembers that one where I just like, it's ISSA, nobody would respond, and so I was just like, I'm gonna sit here and make you feel awkward. Anyways, so, you know, when we interact with data now, like we use SSL and stuff like that, and so it pretty much equates to we use their public key, right, to send them data. But what if we took that data and our identity gets validated, right? We're a member of the domain, we have access to it. And what if we use that magic merger of stuff, that Venn diagram, and we use a thing called context-based access control? What if we created something really cool? And we use context-based access control, and it takes that data in, and we've appended metadata and all this other type of stuff that applications and everything put on it. And we send that through our file server, and the file server takes it, and we have things like DLP. How many of you have data loss prevention technologies in your organization? You know, do you have social security numbers in there, and do you have all these other things, and blah, blah, blah. And so now not just, better than SSL, like I've encrypted with the public key of a domain, right? So only that domain can open it, right? It's not even a man-in-the-middle thing with a session. It's once an application gets it that knows what to do with it. So now I take this data and I analyze it, and then I make a decision like, okay, I'm going to store this in a certain way. So then we have, some basic concepts of like, identities, so role-based access control. We have context and metadata. We have files and settings that we can do. Like, we're trying to give it some greater level of detail of like authentication access control. But what if instead of just like right now, what if it's just users and users that have public-private key sets, right? What if we gave a policy a private key? What if we gave some of these other things private keys? And what if they could encrypt data that is specific based on the domain and what the domain thinks that it should be doing, based on domain policy that not just that social security numbers should be protected, but that they're protected with their own private key. And that even if a user gets the file, that the data inside of it now is protected with a domain-owned private key, for example. Maybe not registering yet like what that could open up, but so now I take that and I generate another file that then gets sent out to Dropbox with the public key of Dropbox. But now Dropbox doesn't really have anything that they can use, right? Like they might have stuff that's unencrypted in there that I don't care about through my policy or whatever, but for the most part, they'd have to have the private keys of the rest of this data to actually read it. Anybody follow me? Okay. We're going to go into a little bit better detail, but then what I have is this idea of like that files can have encrypted data. Like maybe I encrypted something in there that's just for me and I don't want anybody else to see. So what's different about this? And this was literally the one thing why I had no clue why this could possibly be patentable, was literally just what if I gave public-private keys to not just users? What if I gave encryption keys to policies or to data structures or any number of other things, right? We're kind of doing this with data loss protection technology or prevention technologies and other things. Sort of, they have roles or they have identities or something like that they belong to that you have to be a part of, but it's all pretty much still like we deploy public-private keys based on roles and mainly users. So what if the keys were disposable? So when data gets compromised or something like that, we just destroy the keys and the data's dead, right? Isn't that what happens with PGP when you forget where you stored your keychain? Anybody ever have that happen? Like, and crap, I suck. So I've got a ton of encrypted email that I will never read again. There's that kind of concept. So what if, we'll keep going here, all right? So Dr. Evil, this is the patent, and I know it's impossible, we're going to break it out in a minute. So it's a process. It's not a bullet, it's a silver bullet or anything like that, it's a process. So what if we take that standard set of encryption, that standard set of encryption libraries and actually make it applicable. Now we give you a means in which to do this. So now as software developers, it's not just an issue of having a framework that does it for me. Like, yeah, although this would eventually, it would ideally be applied this way, right? But what if everything applied a standard framework that doesn't, that's open source? We'd all be playing on the same field. We wouldn't have to pen test every single little implementation of how we do encryption because we're all doing it the same. So I'm going to introduce one of the things, oh, too far. No, don't do this to me. Let me do this. Let's go back here real quick. So one of the things that I want to identify here is so we have two different base concepts. Right now, trust domains. Anybody know what a trust domain is? It's users, devices, applications, role-based stuff, blah, 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 domain stuff, all the stuff that your domain policy provides. Well, we're starting to get away from devices and applications being inside of that, right? Because, they're being produced all over the place. So what if I use, users, applications, users, domains, devices? Then we have data domains, right? And a data domain would be where we take things like, where we organize and aggregate data into meaningful things to our organization or things that we want to protect. But the problem is that right now, data loss prevention is focused on users accessing things in context to this, and we then rely on, even though we have data prevention technologies that are monitoring these things, they can't do anything to protect them outside of the trust domain. They're all based around whether or not the trust domain actually allows them outside of it. So like what happens when, everybody's perfect example, Snowden, right? He walks out of the building. Did the data loss prevention technology do anything for them? No, because I didn't install that stupid piece of software that's running anymore, so it doesn't do anything. So let's talk about how we can bridge data and trust domains. And so my big mantra last year was data protection, not data loss prevention. Now, I'm not talking about Turing machine code and things like that, like Adobe PDF and what it was supposed to be, where you have self-protecting data and things like that. No, this is way more simple than that. You don't have to install an application. It's a process, right? Data never leaves before it's encrypted. And even when it does leave, it's encrypted with a private key that you may not have. And so if you don't have that private key, you can't open the data, theoretically, right? All right. So what we have happen is users generate data in context of devices and applications. We have user identities when it's in the context of a domain. Those users get authenticated with a process pipe and a AAA process pipe. And so the idea of the framework is not to exclude anything. The idea behind a process pipe in this process is to allow you to use Novell if you friggin' want to, or to use OpenLDAP or Active Directory or, I don't know, smoke signals or something. I don't know. But you generate data, and can we make this sense that in these verticals, data doesn't necessarily need to be shared horizontally? Okay? It can be, but the application doesn't necessarily need to see what the user's generating. Like when you generate a Word document, how much of that Word document is the text that you enter in, and how much of the rest of it is how Word processes and formats stuff? Does Word need to see that data to make your document work? I can tell you it doesn't, because I've actually screwed around with encrypting pieces of stuff in there. Now, does it know what to do with it? No, but it can make it bold. So we're gonna, that's just an idea to throw out there. But then we run down through this process, as the process runs down, we generate data, data gets aggregated, the file gets created, right? The user digitally sign and encrypts it because it's the owner in a domain concept, or in a domain context. The user is the owner of a file, right? Following me? Generate a Word document, look at the owner, people. Then domain user gets validated, encrypts, and forwards the data onto the domain for storage onto a file system somewhere, right? So now we enter into this data domain concept. And so we have concepts of what is a field? So we have some abstract concept of what a field might be. So it might be the first three of a social security number, right? So, everybody always can see, even the guys at Verizon can see the last four of your social security number to validate you as a user, right? So we may have to divide those down into different fields. But then you have data types, which is all three sets, the nine, how many, 7, 9 numbers, whatever it is for a social security number, that equals a social security number, so that's a type. And then you aggregate those into an object model, which would be your identity, so a social security number plus a phone number plus all these other things. And then you put those into a data model, and so then what happens? Well, DLP, we have this policy decision point process in DLP and some of these other things they actually have policies on like how data, how to identify data and how to, when do I alert if a certain level of user has touched it and things like that. Anybody follow me? All right. Yes. This is academic, so I have to make sure that I'm not putting everybody to sleep. So what if we extended this schema and like instead of just having like a policy decision point, added context to that? And what if each of those contexts, so we have like key and certificate management. I see my buddy Jason over there from ways away. I remember certificate management, right? That was a big deal. Like how do we rapidly deploy keys and certificates and other things? And I can't talk about why. I know, anyways. Sorry, Jason. You can go ask him about a cool project that he was working on years ago. Like what if we extended this schema and gave public-private keys to, like I said, applications, data types, file system tags of all things, right? Like OS X. What if we could restrict access and encrypt based on an OS system tag? That'd be kind of cool, right? Like I don't even have to, like, I don't care where the file is. I apply a tag to it and boom, it gets encrypted with the, with the rules that I set for that data tag or something. So you extend that stuff out. And then how do we put all this stuff together? Well, data protection domain is kind of the methodology by which you do this. And so I'm kind of zooming in here to show you how this stuff kind of links together. And then I'm going to zoom in real quick because I'm probably going to run out of time or they're going to hook me off the stage. And I'm not Jason Street, so they will probably like just cap me in the knee or something and I'll have to crawl off of here. But a protection domain is so it's the bridge between trust domains and data domains. And so what I want to do is add context, add policy, and then create a means to generate policy around this. And so we have things that we do this with all the time, right? Like URIs, application developers, use a URI and things like that are like, abstract, identifiers for purposes of, aggregating certain types of data so it's faster to, call it or whatever. So what if we use some of those types of basic concepts and we, in this data protection domain, when data comes in, we inventory it at the PDP. We allow different process pipes, and I think it was on this. Oh, yeah, it's still right there. So as the data comes into the policy decision point and the policy process opens it up, I can't read that. I don't know how in the world you guys can. You have content correlation processes, all right? So processes that are saying like when these pieces of data exist together, then I want to do this with them. And then you have other things like content analysis, okay? So that's your data loss prevention technology that exists now, right? So we're not creating any new technology. We're not pissing on the vendors. We're not locking them out of anything like they did to us. We're not creating anything. We're saying this is a process. You want to have your latest AAA, Active Directory. I'm not saying you can't use it. You need to do it here. And then once data comes out, it needs to come out this certain way. And so once it comes out, like we can key insert management. This patent does not cover those things. That's not the intent. There's a lot of great technology and great development that's being done in those areas. We just want to provide a standard way for these technologies to interact and to play nice with each other. And so that way, if I want to have my open source PGP type of file encryption deal, that I can do it. So then policy process, so then that session ends and it spits out data. And that data might be encrypted like we showed before, where like a role has access to certain pieces of data inside of it, and it's encrypted with that. So, but it comes out after all those determinations are made. So policy is created, context appended to the file, and then it's forwarded back to the domain for storage. And so once that data comes back, and my mouse doesn't work, so I can't like circle it. I should add like a laser pointer or something. Sharks with freaking laser beams. There's an Austin Powers reference. So we have now what I call schema extended data publishing. Okay, and what does this mean? It means it's stored somewhere, file systems, virtual memory, I don't know, wherever data gets stored for this particular piece of, meme wonderful goodness of, that you've generated, that your text file or whatever. And so, so you have data that's published with the private key, or with, that's encrypted for the machine. You have data that's encrypted with the private key of the application, so only that application or developer can open it, for example. So we're still talking in verticals here at the same time. So I'm not exposing data left and right to, a user data to the application that doesn't need to be exposed. I'm not exposing data to other things that doesn't need it. And then the data gets published back. And so, and then what this allows, though, is that because data is owned in the context of a domain, unlike PGP, if I want to share with 10 different users accessing it on a file share, how do they access it, right? Well, they don't. Anybody follow me? Like, you have to have the private keys of that, or the public keys of that user to send them the encrypted data, and once they do it, you don't have any control over what they do with the data because they now own it. Anybody follow me? Weaknesses in existing technology. or limitations in it. But the difference now is that we've encrypted it with a private key of a domain or of a policy decision point. And it may be an organizational domain. It may be something that you own yourself, because the idea behind this is open source. So we want to create, ideally, we're going to in the future create your own, policy decision point that you can have for your data that you generate in the context of your user identities and other things, your email domains and so forth. And so once you do that, we then kind of, let me go back because I'm already jumping ahead of myself. So I just want to make sure before I stop. I'm rambling and I'm going very fast because I've got a lot of data to cover. Am I making any sense? Anybody, this kind of changing anybody's mindset? Say again? Were you trying to? Not really. So there's this thing called a beautiful mind, and no, I don't have one. If you really could read everything that's going on in my mind, it starts with like F this, da da da. So one of the things that I call attention to, and the difference in this framework as opposed to a lot of other open source frameworks, and why a lot of open source frameworks, in my opinion, are rejected by major organizations, is because they feel like it prevents them from having access to do something or to make money off of it. And that kind of was, and I know everybody they want to think that, oh, that's evil or whatever, but no, like some vendors, like a lot of vendors, they provide a legitimate value for something. They answer a question or a problem that an organization or an individual has, and they're developing something to make your life easier, hopefully, right? So like, what value do you have by locking them out of it? Well, then you lock yourself into a proprietary solution. So there's a couple of companies that are trying to do this type of stuff, like encryption throughout the pipeline and protection, and where you have keys and things like that, and role-based, like how do I share a file with, put a file on a file share that multiple users can access simultaneously, but maintain it encrypted all the time. These types of things. The problem is that most of those technologies, because they're afraid of people stealing them or whatever, are closed. They don't want to allow people into them. So what if we don't close this off? Let's add a process pipe for all these different services. And obviously we have to do it for future proofing, right? Like, I have no idea what awesome new data something technology is going to exist in 10 years. I have no idea. TCP version 6 may actually work, right? And we might do something cool with it. Just saying. I don't know. So the intention of this is to allow some level of future proofing, to allow new technology to enter the process, and to do it in a controlled way, and to have that access that they need to do it. So some of the things that that this technology, or that this process framework stays away from, is like identity and access management. There's so much stuff out in that space, OpenAuth and all these other things that work well and do what they need to do. But problems with them are usually, like we said, they're not attacking OpenAuth necessarily. It may have a vulnerability, but like when it attacks encryption tied to OpenAuth, it's probably because it's not implemented at the right layer, right? We kind of starting to see how like some of the vulnerabilities in some of these things, probably would be thwarted if we encrypted it at the right place and it never went below a certain layer in the stack, unencrypted, maybe. Certificate management, there's lots of cool tools out there that do that. Data storage and transport, ultimately, it doesn't matter anymore, right? Because it's going to be stored. It's not going to go down to a session layer protocol and get transferred anywhere without being encrypted, right? So maybe that stuff is dead. Maybe TLS doesn't need to exist anymore. I don't know. The reality is like, is this without its potential problems? No. But so I talked about like active access control. And what that means is like, so I have a policy decision point that when, Jason Street wants to read a file on his thing, or, James over here wants to read his, or Jason over there wants to read that, they have to come back. They may have the file, but it's encrypted, right? And it's encrypted with private keys that they may not necessarily have locally to them. So what they do is they take that file and they send it to the domain. They send a request to the domain, and they send a journal of it, a journal of that file. And the file gets verified that, yes, it is that file. And the domain says, this is what I have. And, oh, yeah, you are authenticated, and I validate you, and you have access to these different things because you're part of these roles or whatever. And then it takes the keys that it has and it unencrypts them with the private keys that it has in store, and then it re-encrypts them with your public key. So now I have attribution, right? I now can see, and so then when you submit the file, but you make your changes and you submit it back, I've got journaling, right? You're kind of seeing how this chain starts to go back around and how this use case starts to continue. So I don't have much time, I got 5 minutes left, so I can't really go into all of how that works. So my goal is, hopefully in showing you this, is that it opens up a big, opportunity to change the paradigm in which we share information and do it in a free and open source way. So some of the things that, so when your key gets compromised, what happens? Well, who cares? I revoke your key, you have that data, and maybe they can, unencrypt, whoever has the files and has the private key can encrypt data to that specific private key, right? But theoretically, there may be 8 or 9 or 10 or 30 or 50,000 different private keys encrypting different portions of that document. So they'd have to work pretty hard to compromise a lot of them. But also, all I got to do is revoke the certificate, because when they try to open the rest of it, they got to go to the domain to request it, and the domain says, that certificate's bad. I'm not going to allow you access to it anymore. And the domain can make a decision. Does it want to destroy the data now that that private key is done and totally trash it and delete that private key and everything that was ever encrypted with it die? Or do I want to take everything in my journal that was encrypted with that, open it back up, re-encrypt it with a new private key, and then destroy it? That make sense? Okay, so now I've got either complete data destruction to the extent that that they don't have all of the keys, so you get into this trust-based thing, right? Like, now I have a means to establish trust in users, like how many times have their keys been compromised, how many times have they reported them, and so forth. But it requires compromising more than just an identity. And that's really important, because identities, Facebook, blah, 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 they get compromised all the time. So what we're talking about here, though, is now we have limited data exposure. So, again, another kind of small slide. What do some of these things provide? Asymmetric encryption provides this confidentiality, man-in-the-middle protection. So even if I man-in-the-middle this with SSL, I'm not going to get anything because I have to have those keys as well. And they're encrypted with public keys that have private keys that I have to compromise both private keys to get, and da-da-da. So I get integrity. One of the things that we do not have in our current stuff is non-repudiation. I know exactly who modified that file and what they did to it, for example. And with PKI, if you implement it in a certain way, it requires online access control to do certificate revocation and to request those keys. So metadata gives us tagging, support for multiple access control mechanisms, attribute-based stuff, and blah, blah, blah. We get journaling, which is, obviously makes sense, supports trust models. I can actually see every machine that opened that file, and if that file was encrypted, blah, blah, blah. Well, okay, so a compromised machine had that file stored on it for some period of time. Were private keys ever on that machine that could have, exposed certain portions of data in that document? Anyways, I'm getting a little bit out there maybe now for some of you. So then we have some stuff like, how do we do search within encryption? That's where you get into this machine-based ontology, like how do you search for data inside encrypted files and things like that. Like, that's a little bit beyond the scope of this, but I'll talk about that later. Some of the things that don't change with this, key storage, you have to protect the keys. But what we do provide, what this type of a framework would provide, is like a means to revoke them and limit exposure to data, which we don't have any means to control right now. And it gives us a trust and repute model. Some of the things that are a little bit not so practical with this are like, I'm streaming something, or, streaming video files. Okay? I'm streaming YanCat. To all of you right now. Go to this website. So some of those types are a little bit impractical, right? Because they're time sensitive or whatever. So me encrypting every little thing is there. But we actually solved that issue, and that's a whole other patent. But how to use public-private keys and one-time use SSL tokens and other things to exchange them. But that will be open source too, coming in the future. Processing network overhead might be a little bit more intensive, right? But theoretically, it may be a hell of a lot less intensive, because we're not encrypting at all these other layers and sending data back up and down and things like that. So to be determined, right? So attacking the framework. Yeah, somebody's going to attack it. The biggest thing that I get is like, what happens if my policy decision point, what happens if my domain gets DOSed or whatever? Well, what happens when your domain gets DOSed now? Thank you very much. The biggest thing that we saw, and that we did not realize this last year, was that and it was patent trolls and people coming in and theoretically trying to take something. Like I said, we didn't really see this idea as patentable. This was really a big what if. But then, yeah, there's some real ways that this could be done. You could attack rules on policy. You can attack the implementation of how you do it. Like, poor policy implementation could definitely allow unauthorized use and things like that. You can attack libraries, But the idea is that if you open source the libraries and you make the process standard, just like, OpenSSL got hacked, right? But why did OpenSSL get hacked? it really wasn't OpenSSL that got hacked as much as it was like poor implementations in certain types of web servers that were using OpenSSL, and the data was unencrypted when it got to the Apache server. You know, that's just an example. But of course, race condition attacks, like where you have issues where like, can I retrieve the file or retrieve a key? So like if I steal a bunch of data and I get a private key, can I do it before you revoke it? Like how much data can I unencrypt before you revoke those keys and I'm no longer able to revoke them? So those types of things still exist. I'm going to quote a line. So the best way to predict the future is to create it. And that was kind of the model for this. And just like, you know, We Are the Cavalry and some of the, you know, and iRonin and all those other ones, like if we actually want to make this happen, PGP didn't create itself, encryption didn't create itself. We have to do something with it. And so we're not creating anything new here. You did not hear me pitch some new technology of something. This is just a means of using existing stuff to use it in a more constructive way that benefits somebody, not a corporation making a ton of money. And that's not to say that companies can't do this. Like I said, we applied technology, you know, like there are process pipes, there are things. You as your company can implement a framework like this and still get paid to have the stuff in there. The idea of it is that you can, you know, that we're providing a standard means to do this, and hopefully some people will understand the value of it and catch on. Some of the ways that we've tested this, I'm not a developer, and so my developers are like, for some reason they like Java, and I hate Java. I call it unicorn poop. So you know, some things like ACML and GeoACML, and what those are is these are XML formats, like ways to format geo information and other things for embedding in web pages and other stuff. You know, like, so how do I create policy based off of those things? So we want to use standards, right? So that we're not the ones saying that this is how it needs to be formatted and it's arbitrary, and you know, no, you use the standards that are out there. And so what we did back in January, it's January of this year, we received a provisional patent protection so that I could come and show you these slides and come and show you this stuff for not having fear of somebody from some corporation going out there and racing me to a condition to patent certain things. And so, you know, is this a complete deal? Is this a done deal? No, it's not. It's still in development. It started as an idea that literally I drew on a bathroom mirror one day. I kid you not. Like there are pictures of me in underwear snapping pictures with an iPhone of like where I was drawing crazy things all over a mirror. And that was how the idea came to us. And so the same thing is going to happen with you. When you have that great, crazy idea that you think that everybody that saw it, all they were like, why are you in your underwear? It's like, I was in my hotel room. Why is there a beer on the thing? Well, at least it wasn't Coke. You know, anyways, I love that slide. This is how you can get in touch with me. The slides and some of the other stuff are on pentestfail.com. You'll also find like all the videos from this weekend. I'll start tweeting them out once I start getting them done. Just like my buddy Iron Geek, he and I do a lot of conferences together, and so we'll start tweeting them out. He usually reposts them as well, so you can usually find him on Iron Geek and stuff as well. But they'll be on a YouTube page for BSides Charleston. But that's how you can get in touch with me. If you have questions on the framework or anything like that, I'll probably bore the living piss out of you. And there's a lot of really cool stuff that goes along with this framework, but it is open source. Like the slides for this, the diagrams and other things are there, and it's still vulnerable in the aspect that, you know, people could come in and steal stuff. But I'm at the point now where I'm like, well, we have a base protection. The more people that we tell about it, the better. If you're a cryptographer, if you're a developer, any of those things, you know, and you're interested in contributing some time or effort to the project, we'd love to see you. Right now it's just me and a couple of guys that make unicorn poop. So thank you very much.